Here we are with the second video for section 3.7, and I will apologize for that last video, mainly because I've had cell phones interrupting different places, and so hopefully I've taken care of that from now on. Continuing, we're still in the same group, I just ran out of time, and that was example number 6. 2 cosine of theta plus 1 equals 0. Once again, we are solving for theta. We only have to go around one time around our circle because that's what the coefficient for theta is. Subtracting both sides by 1, we get that, and dividing both sides by 2, we get negative 1/2. Now we look, cosine can be negative in quadrants 2 and 3, and the reference angles will be the same in both cases, where the cosine equals 1/2 is at pi over 3. Since we only have to go around once, I have to name this angle right here, which is theta would equal 2 pi over 3, or theta would equal, going around to here, 4 pi over 3. Only have to go around once, and so there is our final answer. Now the next group says solve the equation and give a general formula for all the solutions. And so what we're going to do is we're going to start out exactly the same way. Precisely the same way. If we have to go around twice, we're going to do so, and then we're going to start looking at some patterns. And so we get the cosine of theta equals 1. Now here there's not a whole lot to solve. Basically we immediately go to, okay, where does the cosine of theta equal 1? Well, the only place that occurs is right here on the positive y-axis. I'm sorry, that would be the sine. The cosine equaling 1 is here on the positive x-axis. And so that means theta will occur at 0. Now if we just had to go from 0 to 2 pi, we would be done, because we would only have to go around once, and we've already named it at 0, and then we don't need to worry about it from then on. The problem is it occurs every 2 pi after that, and the question becomes, how do we show that it occurs every 2 pi after that? Well, we just take our answer, 0, and add 2 pi n to it. Because it happens every 2 pi, we put 2 pi. If it occurred every pi, we would just put pi. If it occurred every pi over 2, we would do that as well. Now obviously we never like to see 0 plus 2 pi n, so this can be more easily written as 2 pi n. And understand that n just simply means any integer. And as soon as we do that, this is our final answer, 2 pi n. Let's go a little bit deeper into this one, or into this type of problem, and that is number 8. Number 8 says the sine of theta is equal to root 3 over 2. Okay, well, there's not a whole lot of solving to do here. Sine is positive in quadrants 1 and 2. Reference angles will be the same. Question becomes, where is sine root 3 over 2? Well, the sine where it's root 3 over 2 is at pi over 3. So pi over 3 would be the reference angles in both cases. And so here we would say theta equals this angle right here, pi over 3, or theta might actually equal this angle here, which is 2 pi over 3. But realize, since we're looking for a general formula, it's going to occur every trip around. So we're going to have to take pi over 3 and add, it occurs every 2 pi after that. Likewise, here at 2 pi over 3, if we go around an entire revolution again, we're going to end up right where we're at. And so there is the general forms for both of those solutions. Finally in this group is number 9. The cosine of 2 theta is equal to root 2 over 2. Now here we need to treat it just like we would have before. That being, we're going to have to go around twice to determine what will 2 theta equal. So 2 theta is going to potentially equal 4 things. Because cosine is positive in quadrants 1 and 4. The reference angles will be the same, and specifically, where does the cosine equal root 2 over 2? That's at pi over 4. So that means 2 theta might equal pi over 4. Or it might equal this big angle right there, which is 7 pi over 4. But since it's a 2 here, I need to go around twice. So I'm going to go around once and then end there. That becomes 9 pi over 4. And one more time going all the way around and then ending right here would be 15 pi over 4. So now, solving for theta in each one of these cases, we get pi over 8, 7 pi over 8, 9 pi over 8, and 15 pi over 8. Now here's where the general form is actually a little bit easier, because if we look at pi over 8, which is this angle right here, and 9 pi over 8, that's the same terminal side. Oh, wait a minute. Pi over 8 would be here. 9 pi over 8 would be here. Okay, not so much. However, if we look carefully, if this were pi over 8 here, and 9 pi over 8, and then it's going to start again here, and here, and here. Notice that it's just duplicating every pi instead of every 2 pi. So that means this answer can be written as pi over 8, and instead of saying plus 2 pi, it's going to be plus pi n. And that will take care of this one here and this one here. If we look at 7 pi over 8, well, 7 pi over 8 is right there, and 15 pi over 8 is about right there. And so we start here, go halfway around, halfway around, halfway around. In other words, if we go half a revolution, it starts repeating as well. So that means it'd be 7 pi over 8 plus, not 2 pi, but just pi n. And that is sufficient for the answer. Even though we had 4 potential answers, that allowed us to say, okay, you know, it starts repeating every half revolution instead of every full revolution, and so we've got a little bit of a simplification, I guess, so to speak. The next asks us to use calculator, and since I cannot show the calculator, it's just a matter of punching these in. Realize that we're going to possibly need to do some solving beforehand. But once we do, it's just plugging in some arc functions. Number 10, the sine of theta is equal to 0.36. And so we are asked to do it on the interval from 0 to 2 pi and round to 2 decimal places. So we do need to do a little bit of thinking here. Sine is positive in quadrants 1 and 2. So when we take the arc sine of 0.36, that's only going to give us this value right here. And it is approximately 0.37 when we do the rounding. So the question becomes, what is the name of that angle? Because we also need that one as well. And how we do that is, well, if we would go all the way around, this is pi, and we fell 0.37 short. So pi minus the 0.37 might give as our other answer 2.77. Question number 11 is very similar. The cosine of theta equals negative 0.52. So I'm going to come over here and realize cosine is negative here and here. So whatever the answer is going to be, is going to, well, if we find the arc cosine of negative 0.52 in our calculator, making sure that we're in radians because that's what we're talking about, actually gives us the value 2.12. But it's very important to realize that's this angle right here. That angle is 2.12. So now the question becomes, how are we first of all going to calculate this? Because in order to calculate this, we have to take pi and add this, but this angle right here is the same as this angle. So how would we find this angle? Well, that would be take pi and subtract 2.12, which gives some value that I'm not really sure of. But once we find this value here, then all we have to do is take a pi and add it to this. And when we do that, we end up with the entire angle right there to be the angle 4.17. And the final example for this particular video, number 12. 3 tangent of theta minus 8 equals 0. So we need to do some solving here before we can actually punch it into the calculator. So it's 3 tangent of theta equals 8. The tangent of theta, when we divide both sides by 3, is 8/3. And so we look very quickly. The tangent is positive in quadrants 1 and 3. The reference angles will be the same. Luckily, when we take the arctangent of 8/3, it gives us the value of 1.21, which is that value right there, or that angle right there. So to find this whole big angle right here, all we have to do is take the pi plus 1.21, which gives us a value of 4.35. And so the two answers here would be 4.35 and 1.21.